This video is for training purposes only and should not be used as a replacement for any technical publication.
Many environmental control system issues reported on the ATR 72 and 42 platforms can be attributable to preventable loss of system performance. In this video, we will examine the most common cause of reduced system performance, along with some simple maintenance activities that may be used to maintain optimal ECS performance. Let's start by taking a look at some system performance capabilities. According to the ATR 42 and 72 technical specifications, along with these assumed conditions, the air conditioning system shall maintain a temperature difference of 8 degrees between the cabin and the outside air temperatures. The two factors most often result in performance degradation are leakage and blockages. Leaks and blockages may also reduce ECS component reliability. We will now look at common types and locations of system leaks. We will begin by looking at the system hoses, ducts and clamp connections. Braided connections are used throughout the whole of the ECS. Black staining around the hose circumference is typical leakage indication. This may be caused by loose clamps or degraded hoses. Ensure that hoses are fitted correctly for their applications. Poorly fitted hoses may lead to system leakage. Over-tightening the clamp may strip its worm drive or crush the hose. These kinds of damage will degrade the sealing efficiencies, once again potentially leading to a leak. Also, be on the lookout for hose misalignment, as this may lead to hose separation and system leakage. Alignment of all hose and duct connections must be parallel, with the hose fitting squarely around the circumference of the duct. These are some examples of corrective actions for misalignment. The constant bleed air hose to the ACM prevents ice buildup at the turbine. The integrity of this constant bleed air hose is very important, as holes and splits will compromise the anti-ice protection of the ACM and its reliability. Replacement is the only corrective action for this type of damage. Heat exchanger leakage will divert airflow from the turbine, thus reducing ACM speed and decreasing the efficiency of the ECS, ultimately affecting ECS performance. Replacement is the only corrective action for this kind of damage. System leakage recap. System leakage is most common from the hoses, ducts and from the heat exchanger. Leakage will divert air from the ACM turbine and reduce its rotational speed, degrading the ECS efficiency. Even a small leakage may result in noticeable differences in stabilized cabin temperatures. ACM icing conditions may also occur and increase the probability of turbine FOD. Needless to say, this will reduce efficiency and reliability of the ACM. A blockage will also affect the system performance. The system functional zones that are most susceptible to blockage include the heat exchanger, the condenser and water extraction system. When there is a blockage on the cooling side of the heat exchanger, the ACM rotor speed is minimally affected. However, blockages will often decrease the ECS cooling efficiency by degrading the system performance. For example, the 30% blockage illustrated here may cause uncomfortable 3 degrees temperature increase in the stabilized cabin temperatures. This definitely qualifies as degraded system performance. Air from the condenser enters the water extractor. The helix of the internal vanes spins the air. The heavy water droplets are centrifuged outwards towards the duct wall. The heavy water droplets pass through the perforated inner sump wall. As the water collects in the sump, bleed air forces the water out of the drain tube to the water spray nozzle at the heat exchanger. Dry air passes through the tick valve and enters the turbine section of the ACM. The water extraction system uses the system pressure to force free water collected in the sump of the water extractor through a small diameter hose into the spray nozzle. The spray nozzle directs the extracted water onto the cooling side of the secondary heat exchanger. The water evaporates in the ram air, improving the cooling efficiency of the secondary heat exchanger and the ECS system. Degradation of the water extraction system will have a severe effect on the cooling efficiency of the ECS by reducing the evaporative cooling effect of the water, elevating the exit temperature of the secondary heat exchanger by as much as 10 degrees centigrade. This will cause significant performance drop of the ECS. A blockage in the water extraction system prevents the extracted water from being removed from the system, allowing it to enter the ACM turbine section, where it will turn into ice by the sub-zero effect of the energy removal created by the turbine wheel. It will also affect the evaporative cooling efficiency of the system, elevating the exit temperature of the secondary heat exchanger by as much as 10 degrees. This again will cause significant performance drop of the ECS. A blockage in the drain tube will restrict the extraction of water. The free water in the condensed bleed air cannot be extracted and enters the turbine section of the ACM. Using these maintenance tips will optimise the performance and maintain the reliability of the ECS system.